Hello there and welcome. Today what we're going to be discussing in this video is atomic math, or how to go ahead and do the calculations that you're going to be required to as we progress in this unit. Now the calculations are going to be involving ions, isotopes, and the periodic table. In these we'll be looking for your number of protons, neutrons, electrons, and figuring out these variations when applied to ions and isotopes. So a little bit of math is going to be involved, but hey, if I can do it, just about anybody can. Let's go ahead and get started. So, when going ahead and looking at a periodic table, you're going to see a wide variety of these little boxes. Now, the top one, up top here, corresponds to, if you look at the number 8, that is the atomic number. The O is the symbol, or atomic symbol. Where it says oxygen, that's, well, the element name. And at the bottom here, this is what we call the atomic mass. Now, as you can see, this says 15.999. What we're going to go ahead and do is, for just the sake of levity, we will be rounding that to the nearest whole number. So either you're going to round up or round down. Round up if it's above 0.5, round down if it is below 0.5. So 15.99, we're just going to make that 16. Now, if you think back, remember that the atomic number equals the number of protons or electrons, whereas the atomic mass corresponds with the number of protons or neutrons. So let's go ahead and fill this in. Let's go ahead and do oxygen. So if we look at oxygen, we know the atomic number is 8. The atomic mass, 16. The number of protons, which is 8. Now I'm going to skip neutrons for a second. I'll come back to it. The number of electrons, same as the number of protons, so it's 8. And finally, to go ahead and find our number of neutrons, we're going to go ahead and take our atomic mass and go ahead and subtract our number of protons or our atomic number. So 16 minus 8 would give us 8. And just for the sake of completion, let's go ahead and fill that in. There we go. So I'd like you to go ahead and real quick pause the video, use your periodic table, and fill in the rest of these two examples. I'll go ahead and meet you on the other slide when you're finished. So, just a few things. A way to go ahead and remember the calculations. A way to remember this is with the acronym APE-MAN. So APE, we're talking about the atomic number. So APE is the number of protons, which is P, or the number of electrons, which is E. So A equals P equals E, APE. So the atomic number is always going to be the number of protons or electrons. Now the second part of this, MAN, corresponds to the atomic mass. So to find your atomic mass, you're going to go ahead and take your atomic number and your neutrons, the atomic number being A, neutrons being N. So to go ahead and find your number of neutrons in an element, you're going to take your atomic mass M and subtract your atomic number A. So let's go ahead and take a look at calcium. So pause it if you'd like, but we're going to go through this. So the atomic number for calcium is 20. So our number of protons is going to be 20, and number of electrons is also going to be 20 because APE. Atomic number is protons or electrons. Now as far as our atomic mass goes, if we go ahead and look here, our atomic mass can be found at the bottom. So our atomic mass is going to be 40. Now we know that our atomic number, A, was also 20. So if you go ahead and subtract the two, our number of neutrons is also going to be 20. That's just how this one worked out. It might not work out like that every time. Anyway, so it should be number of protons 20, electrons 20, atomic number 20, atomic mass 40, and our number of neutrons is also going to be 20. So let's go ahead and try to do things a little bit differently. So this is just the normal everyday calculation, but let's go ahead and include, so the first thing we're going to look at here are isotopes. Now an isotope, these are atoms of an element with a different number of neutrons, so it has a different mass number or different weight, or atomic mass. So the protons and electrons will not change, but the number of neutrons do, changing once again the atomic mass. So radioactive isotopes have a wide variety of different uses and are often used as tracers in medicine, which we'll talk about slightly on the next page. So we're going to go ahead and do one of these together. We'll do the first one, boron, and then from there, if you'd like a bit more of a challenge, I encourage you to go ahead, pause the video, and work your way through the other two sets of problems here. So, if we go ahead and look at boron, on the periodic table, boron has an atomic number of 5. Now the atomic mass of boron is normally 11, but as you can see here, when it gives it to you like this is always corresponding to the atomic mass. So our atomic mass here is 15. Now from what we know based off the previous slide, remember ape. A equals P equals E. So the atomic number is going to be the same number as our number of protons, which in this case will be 5, and our number of electrons, which will also be 5. Now to go ahead and get our number of neutrons, remember M, A, N. So your atomic mass minus your atomic number will give you your neutrons. So if we go ahead and take our atomic mass, which is 15, and subtract our atomic number, which is 5, that's going to go ahead and give us 10. So our number of neutrons will be 10. So like I said, go ahead, pause the video, and I encourage you to work through the rest of the two problems on your own to see how you do. So like we said earlier, the medical uses of radioactive elements. For example, if you go ahead and swallow radioactive barium, this can allow doctors to go ahead and see the large intestines. Now, considering that the large intestine is not a bone, or have any bones in it, normally, if you do, please consult your physician, but this allows them to go ahead and see soft tissue, like this large intestine, on an X-ray to go ahead and determine if there's anything wrong with it. So finally today we're going to be taking a look at ions. So remember, an isotope was a change in the number of the atomic mass, or a change in the number of neutrons. An ion, however, is a change in the charge, or a change in the number of electrons. Remember, you cannot change the number of protons in an element, because if you change the number of protons, you're changing the atomic number, ultimately resulting in a different element entirely. So you don't want to be doing that. So, an ion, these are atoms of an element that have a change in electrons. So, think back. A positive charge means we lost an electron. A negative means we gained an electron. So, if it's a negative charge, that means we're going to be adding electrons. Meanwhile, if it's a positive charge, we're going to be subtracting or losing electrons. So let's take a look at our first one here. We'll do the first one together, maybe the first two together on this one, just to make sure you have it. And I'd like you to go ahead and do the last one by yourself. So, feel free to go ahead and pause the video after we do the first two. So, boron, like we said before, boron has an atomic number of 3, which we got from... Good. That's where we got it from the periodic table. Now, it has an atomic mass, normally, of 11. Now, considering that the proton is always equal to the atomic number, we know we have 3 protons. Now, normally, protons and electrons are equal. But in this case, if you take a look, we have a plus here. That goes ahead and tells us that in this case we have a positive charge. Now, if there's no number there, that I want you to go ahead and assume that that means that it's either positive 1 if it's plus, or negative 1 if it's minus. So it has a negative 1 charge if it's negative, a positive 1 charge if it's positive. So, in this case, we have a positive 1 charge. So if you take a look, positive means we lost that many electrons. So in this case, what that means is we lost 1 electron. So if we go ahead and we normally have 3 electrons, but we lost 1, that means now we have 2. And remember to go ahead and get your neutrons. All you do is go ahead and subtract your atomic number from your atomic mass. So 11 minus 3, that is going to give us 8. So, Let's go ahead and do one more example, but this time it will be a negative element. So, we have carbon. Once again, if you go ahead and look at the periodic table, carbon has an atomic number of 6, has an atomic mass of 12, so the number of protons is going to equal the atomic number, giving us 6. Our number of neutrons, to get that, we go ahead and just simply subtract the atomic number from the atomic mass. 12 minus 6 is going to give us 6. Now, if you look at the charge on this one, you'll see it's negative. Specifically, it's a -2 charge. So, remember, if it's negative, that means we add that many electrons to the total number. So, originally, in this example, protons and electrons were equal. So we had 6 protons, 6 electrons. But you're going to go ahead and do the opposite of whatever the sign tells you. So since it's negative, -2, we're going to be adding that many electrons to the number, taking us from 6 electrons to 8. So if you take a look, that means now we have 2 more electrons than we do protons, giving us that -2 charge. So I would encourage you to go ahead and do the last one on your own, see what you do, see how you do. Give it a shot. Now with that is going to go ahead and close today's lesson. We will be practicing this quite a bit in class, so just be prepared. This was supposed to be an introduction. If you have any questions, I'm sure your instructor will go ahead and walk you through it, help you out as you see fit. And with that, that's going to close us off for today. So thank you very much for your time, and until next time, you go ahead and take care of yourself.